Hi everyone, welcome to my channel again. In this video, I'll be doing two questions. Both are related to simultaneous linear equations with two unknowns. For questions in this topic, they are usually given in this format. Here, you're given two equations and two unknowns, x and y. So the question will ask you to solve these two equations. The meaning is, the question wants you to find the value of x and y that will satisfy both equations. Okay, that's the meaning of solving these two equations. But here in this example number 1, you can see that the format is very different from this. But don't worry, because 2x plus 3y equals y minus 2x equals 7, we can actually separate them into two equations. Because we know that 2x plus 3y is equal to 7. And we also know that y minus 2x is equal to 7. See, it is very easy to separate them into two equations. And now the format looks exactly the same as this. So to solve these equations, there are actually three different approaches. But in this video, I'll be talking about only two approaches: method of substitution and method of elimination. Why don't we start with this, the method of substitution? The meaning of substitution is that first, you pick one of these equations. So say I call this 1 and I call this 2. So you pick one of them and make x or y to be the subject of the equation. Say if I pick equation number 1. Let's say I want to make x to be the subject of the equation. What's the meaning of that? The meaning is you want to do some mathematical operation such that at the end it is x equals something. So how do we go from this step to this step? It requires some very basic mathematical operation. First, you want to move 3y from the left hand side to the right hand side. Now we divide both sides by 2. Okay, so we have reached this step. X is being the subject of this equation. I'll call this number 3. After we have this here, okay, we substitute this back into the x here in equation 2. So y minus 2x, x is this here, 7 minus 3y divided by 2 is equal to 7. Now we have one equation with only one unknown, so this is very solvable. So we do some simplification. 2 divided by 2, they cancel each other out. This becomes y minus 7 plus 3y is equal to 7. So y plus 3y is 4y. Minus 7, I move it to the right hand side, so it becomes 7 plus 7, which is 14. So y is equal to 14 divided by 4, which is equal to 7 divided by 2. We know y is equal to 7 divided by 2. Are we done yet? No, we are not, because we haven't found x yet. So why don't we substitute this 7 divided by 2 back into equation number 3. So look at equation number 3 again. X is equal to 7 minus 3y, which is 7 divided by 2. And then the whole thing divided by 2. Okay? This is equivalent to 7 divided by 2 minus 3 times 7 divided by 2 times 2. So this becomes 4, because 4 is the common denominator of 2 and 4. And this becomes 7 times 2 minus 21. So 7 times 2 is 14, minus 21 is negative 7 divided by 4. And y is equal to 7 divided by 2. So if you are unsure whether you are doing all these operations correctly, there's one way to verify your answer. You can substitute 7 divided by 2 back to one of these two equations here. Say if we look at equation number 2. We look at the left hand side of this equation number 2, which is y minus 2x, right? So we substitute this value and this value back to this formula here. So it is 7 divided by 2 minus 2 times minus 7 over 4, right? So this is 7, which is the same as the right hand side of equation 2. So we're pretty sure that our answer is correct. So I just used method of substitution to answer example number 1. How about method of elimination? How can we use this method to find the value of x, y of this question? It's actually quite simple because all you need to do is look at equation 1 and equation 2 and try to find some common terms. What's the meaning of that? You look at equation number 1, you can see there's a 2x, right? And for equation number 2, you can see there's a minus 2x. How about if I add equation 1 and equation 2 together? The meaning of equation 1 plus equation 2 is that you add the left-hand side of equation 1 with the left-hand side of equation 2, and you do the same thing for the right-hand side. The left-hand side of equation 1 is 2x plus 3y, okay? And the left-hand side of equation 2 is y minus 2x, okay? Equals to the right-hand side of equation 1, which is 7, plus the right-hand side of equation 2, which is also 7. The beauty of adding 1 and 2 is I can see that for equation 1, there's a 2x. And equation 2, there's a minus 2x. If I add these two together, the 2x and the minus 2x, they will cancel each other out. This is exactly what we see here. We have a 2x, we have a minus 2x. So these two cancel out. So what we are left with is 3y plus y, which is 4y, is equal to 7 plus 7, which is 14. So y is equal to 14 divided by 4, which is 7 over 2. This is exactly the answer we found when we used method of substitution. So after we find y is equal to 7 divided by 2, we can substitute this back to either one of these equations. Why don't we substitute this back into equation number 2? 7 divided by 2 minus 2x is equal to 7.
So 2x is equal to 7 divided by 2 minus 7, which is equal to 2 over 7 minus 14, which is minus 7 over 2, okay?
So x is equal to minus 7 over 4, okay? Again, exactly the same answer as what we found when we used method of substitution. So here it is a matter of choice as to whether you want to use this method or this method. So what I will suggest is, if you look at these two equations, if you find something to be the same, right, like here, 2x minus 2x, right, then it is easier to use method of elimination. Okay? For example number 2, I can show you that by using method of elimination is far superior to method of substitution. Okay, now let's take a look at question number 2. Here you're asked to solve these two equations. And as you can see, there are two unknowns, a and b here. Okay, so let's use method of elimination first to try to solve these two equations. Like what I told you about when I was working on question number 1. To use method of elimination, you want to find something in this equation. I'll call it equation number 1, and this is equation number 2. You want to find something in both equations 1 and 2 that are the same. But here you can see none of them are the same. 10 over a is different from 7 over a. 3 over b is different from 1 over b. But what if I multiply equation number 2 by 3? If I multiply equation 2 by 3, 1 over b will become 3 over b. And 3 over b is the same as this, right? So why don't we do that? We multiply equation 2 by 3. And we multiply left-hand side and right-hand side by 3. So 3 here, I multiply inside this bracket. So 3 times 7 is 21 over a. Okay, and 3 times 1 over b is 3 over b. 38 times 3 is 114. Okay, so I'll call this equation number 3. So now, if I add equation 1 and equation 3, okay? So this will become 10 over a plus 3 over b. This is the left-hand side of equation 1 plus the left-hand side of equation 3. So 21 over a minus 3 over b is equal to right-hand side of equation 1. So 58 plus right-hand side of equation 3, 114. So here you can see that we have a 3 divided by b minus 3 divided by 3. So these two cancel each other out. So what we're left with is 10 over a plus 21 over a is equal to 58 plus 114. That is 172. So now we do a common denominator because both of these terms here, they have denominator of a, so we can just do this. 10 plus 21 is equal to 172. So a is equal to 31, okay, which is 10 plus 21 divided by 172, okay? So we have found a, so now we use any of these equations, 1, 2, or 3, and try to find b. So how about if we use equation number 3? 21 divided by 31 over 172 minus 3 over b is equal to 114. So here, 21 divided by this, okay, to simplify this, we basically flip this bracket from the denominator to numerator and vice versa. So this becomes 21 times 172 divided by 31 minus 3 over b is equal to 114. Okay, so if I move this 3 over b from the left-hand side to right-hand side, this will become plus. So it becomes 21, 172 divided by 31, and then minus 114 is equal to 3 over b. So 21 times 172 is 3612 minus 114 times 31, which is 3534, is equal to 3 over b. So 78 divided by 31 is equal to 3 over b. Okay, so b is equal to 3 times 31 divided by 78. So that's 93 over 78. So both can be divided by 3. So this is 31 and this is 26. So b is equal to 31 over 26. And that's your answer. So now as you can see, you can find a and b relatively easy. So here are all the steps. If I use method of substitution to solve these two equations to find a and b. So the gist of it is that first I picked equation 1 and I make a to be the subject of the equation. So you can see a is equal to something with b in it. So I'm making a to be the subject. So I call this equation 3. So now I substitute this back into equation number 2. So I basically substitute this back into the a here of this equation 2. Okay? So I do a whole bunch of simplification, so on and so forth. And now I can find that b is equal to 31 divided by 26. So after knowing b is equal to this value, I used equation number 2 again. I put this value, okay, b is equal to 31 divided by 26. I put this value back into here, okay, like this. So then I only have one equation and one unknown, so this becomes solvable. So after a lot of mathematical operations, I find that a is equal to 31 divided by 172. So both the value of a and b are exactly the same when I used method of elimination to find a and b. So I've shown you both methods, method of substitution and method of elimination. Okay, so it's up to your choice as to which one you want to use. But like I said, I recommend you to use method of elimination if possible, because it usually involves fewer steps than using method of substitution. Okay?